Thank you for joining us today. Our webinar titled DOCSIS 4.0, the move to 1800 MHz. I am Crystal Ragland with the Mini Circuits Business Development Department. Today we will be discussing the need for higher capacity in the broadband CATV market, as well as the Mini Circuits response with product offering now to 1800 MHz. This webinar was organized by Mini Circuits Vice President of Technical Marketing, Steven Scheinkoff, who will be available during the Q&A section of the webinar. Presenting on behalf of Mini Circuits is Eric Olson, Product Marketing Manager. Eric joined Mini Circuits in 2018, leading the product marketing team. In his role, Eric is responsible for driving the product and technology roadmaps for the company's high investment product lines, as well as guiding strategic business planning. Eric has over 30 years of experience in the RF microwave industry, has published 8 papers, and has been awarded 1 patent. Mini Circuits is joined by guest speaker Phil McGillis, CTO, Access Vision Technologies, to share his observations of the industry and market from his perspective. Mr. McGillis has over 25 years of experience in cable access network and equipment design and development, both from the supplier side and the operator side. Phil was a leading member of the Next Generation Access Network team at Comcast and worked with the migration from HFC to a distributed access architecture. He has left Comcast at the end of 2018 and is now an independent consultant, working with several major component and system vendors. Mr. McGillis has 9 U.S. patent grants and over 20 published papers, articles, and webinars. He is an active participant at SCTE and CableLabs and is a member of the DOCSIS 4.0 working group that is currently meeting to define the requirements for 1.8 GHz operation. For optimal audio quality, all attendees have been muted. The last 15 minutes of the webinar are reserved for Q&A. Please use the Q&A feature located at the bottom of your screen to submit questions. I will address the questions to the panelists for answer when the presentation concludes. I will also be monitoring the chat option throughout the presentation. This webinar will be recorded and may be published for additional marketing and promotion. Concluding the webinar, a survey will populate to collect your feedback both on the presentation of the webinar as well as the content. We will also be sending a follow-up letter to all attendees. And now, I will hand us off to Mr. Eric Olson.
Thank you, Crystal. Thanks for the introduction, and thank you to all of the attendees who have joined us today. We're very happy to present our story on our cable TV developments, as well as to have Phil McGillis join us today. And with that, I'll turn it over to Phil to give us his insights.
All right, so let's start talking about the 10G challenge. At the 2019 Consumer Electronics Show in Las Vegas, NCTA, CableLabs, and several member companies participated in a session titled The Future of the Broadband Network, which announced the goal of delivering 10 gigabit capable DOCSIS networks. The DOCSIS 4.0 standard now in development is one step in the attainment of a symmetrical multi-gigabit network with the potential of 10 gigabit per second speeds. So what's driving the need for this higher capacity? Beginning with the first audio modems in the early 1980s, the growth of data has consistently climbed from kilobits to gigabits over the past 35 plus years. Innovation and technology feeds consumer demand to download and upload data content at ever-increasing speeds. The downstream peak growth rate had been following Moore's law, but has slowed in recent years to a current year-over-year percentage rate in the low 30s. The upstream growth rate is still increasing, primarily due to the popularity of smart home applications, particularly video monitoring devices. Market competition continues to keep cable operators awake at night as fiber and wireless overbuilders promote gigabit symmetric service offerings. The graphic on the left-hand corner shows the overlap of major competitors to MSOs in a number of key cities across the United States. To address this competition, operators must upgrade to match or exceed the promised high-speed data tier rates of these competitors. On the subscriber side, changing consumer viewing preferences and new services require higher capacity. Netflix is still the highest bandwidth consuming service at this time, but the number of new competing streaming services is rapidly increasing. Disney Plus and HBO Max will surely drive even higher bandwidth usage as they roll out over the next few months. The number of connected devices within the home also drives capacity demand. Only 5 or 6 years ago, operators planned network capacity assuming 3 to 5 connected devices per home. Today, that average is 8 to 10, with high-end users registering 18 or more connected devices to the network. Additionally, new bandwidth-hungry applications are always on the horizon that cable operators need to consider as they plan for future capacity requirements. Next slide. All right, so where do we find room for OFDM DOCSIS 3.1? DOCSIS 3.1 introduced a more efficient modulation format and advanced FEC capability, allowing a 50% bandwidth efficiency increase plus 5 to 6 dB improvement in SNR over traditional DOCSIS 3.0 QAM channel loading. However, the majority of existing cable networks today are limited to 750 megahertz, and most are fully loaded, leaving no room to deploy additional OFDM channels. The upstream is further constrained due to RF spectrum restrictions of 42 megahertz in most systems. Therefore, the only available mitigation for increased channel digital capacity in these legacy networks is still a node split. An RF expansion to 1.2 gig is an alternative, but relies on either FDX to solve the upstream problem, or reclaiming all of the current QAM video and data channels and converting to all IP in order to provide the necessary bandwidth needed for high split return, and still have enough spectrum left over for higher capacity downstream services. The new possibility is extended spectrum DOCSIS 4.0. So what are the goals for DOCSIS 4.0? DOCSIS 3.1 was released in 2013 with tremendous improvements in bandwidth and efficiency and expanded RF spectrum, but the operational specifications in the D3.1 standard were limited to 1218 megahertz. In 2017, full duplex DOCSIS, or FDX, was initially released as an appendix to the DOCSIS 3.1 specification. FDX is still in development from a product perspective, and although it will be able to provide the capability for multi-gigabit upstream performance, the cost and complexity involved in deployment is still being debated, particularly as it affects the use of RF amplifiers. Work on the DOCSIS 4.0 specification is now in process with an expected release in early 2020. The new spec will define operation to the full 1.8 gigahertz band and provide for either frequency division duplex, or FDD, with a high return split, or FDX upstream system designs. FDD operational capability in particular positions DOCSIS 4.0 to be compatible with existing legacy Node plus X architectures. So let's look at the pros and cons of 1800 megahertz operation. For advantages, 1.8 gigahertz frequency bandwidth allows increased digital capacity up to 10 gigabits per second. It also allows greatly expanded upstream bandwidth for high split return. As in past HFC frequency extensions, 1.8 gigahertz will support traditional node plus amplifier cascade architectures, reducing the amount of network construction needed to deploy. DOCSIS 4.0, just like DOCSIS 3.1 that it is built upon, is completely compatible with distributed access RFi or RMAC-Fi. On the challenges side, extending the bandwidth means that hybrid gain block output power, channel loading, and tilt need to be carefully considered. Increasing the raw total composite power and extending the linear tilt line to 1800 megahertz is really not realistic. Tilt flat or step tilt channel loading is being evaluated by the hybrid and amplifier vendors to optimize performance over the full DOCSIS 4.0 spectrum. Additionally, all of the legacy housings, connectors, and associated hardware will need to be reevaluated. Many of the deployed housings were designed in the 550 megahertz era, and many have cavity resonances and isolation issues that will need to be corrected for 1.8 gigahertz bandwidth operation. RF signal loss due to coax attenuation at 1800 megahertz will require higher output levels or higher receiver gain, or a combination of both. The ubiquitous RG6 drop cable to the home may need to be replaced with larger RG11 in order to recover 3 dB of higher signal loss at homes furthest from the amplifier. Probably the most significant potential downside of DOCSIS 4.0 N+X network designs is that node splits will still be required as data usage and the number of connected devices per home continues to increase. So in conclusion, CableLabs is working with MSOs and suppliers to define requirements for the DOCSIS 4.0 standard with a target release in Q1 2020. At the recent SCTE Expo in New Orleans, several vendors displayed 1.8 gigahertz prototype hardware, along with many white papers and innovation talks related to 10 gig or 10G development activities. Component suppliers like Mini Circuits are actively engaged with customers and working to develop components needed for 1800 megahertz operation, as you will hear about in the next part of this webinar. The race is truly on for 1800 megahertz. So with that, Eric, I'll turn it back to you.
Thank you, Phil. I really appreciate the time you've taken to share with us the market drivers and technology overview and your insights. It's clear that DOCSIS 4.0 presents significant challenges and opportunities for all players in the CATV market. Mini Circuits has leaned forward ahead of the new standard to meet these new demands. Let me start with an overview of our current portfolio. Mini Circuits has a broad range of products to support existing deployed CATV technologies, and we have and continue to develop new products to support the emerging standard. Mini Circuits portfolio today includes high-performance couplers, power splitter combiners, low-pass and band-pass filters, diplexers, transformers, and switches. And though not included in this presentation, Mini Circuits also has a broad range of products and solutions to support your CATV test and characterization needs for both 50 and 75 ohm systems. And our existing portfolio covers the FDX portion of DOCSIS 4.0 up to 1218 megahertz. Let me start with our 75 ohm coupler portfolio. We offer over 95 models, 5 of which already meet the 5 to 1800 megahertz band requirements. Our coupler product line ranges from 6 to 25 dB of coupling with insertion losses of less than 2 dB typically and directivity of greater than 18 dB typically. As with many of our CATV products, our couplers are available in surface mount, plug-in, and connectorized form factors. Our splitter line is nearly as deep as our coupler line, with 85 models in total, covering capability of 2 to 24-way split, and with 13 models already supporting the 1800 plus megahertz band, with insertion losses typically around 1 dB and amplitude and phase unbalance typically less than 1 dB and 10 degrees respectively. Our low-pass filter family continues to grow, with 20 models already offered, 2 of which support DOCSIS 4.0. These filters deliver less than 1 dB typical for insertion loss and excellent VSWR. With 3 bandpass filters already supporting DOCSIS 4.0, our filters deliver very high out-of-band rejection combined with low-pass band insertion loss. In our diplexer portfolio, we have excellent selectivity and insertion loss across our 22 products, offering competitive performance, with one model already meeting the full DOCSIS 4.0 requirement and several others supporting FDX portion. Our broad range of transformer impedance ratios and configurations offer many options for CATV designers. 17 of our 45 catalog models already support the 1800 megahertz requirement. And in our switch portfolio, all models of SPDT through SP6T cover the 1800 megahertz band. These switches offer high IP3, built-in drivers, and single supply operation for ease of use. Based on a solid foundation, Mini Circuits has been investing in DOCSIS 4.0, and I'll share some highlights in the next few slides. We'll be covering our splitters, couplers, low-pass filters, bandpass filters, transformers, switches, and a new RF choke model. The key feature of the RDC family of couplers includes low through-path transmission loss, reducing heat dissipation, and avoiding the need for special heat sinking methods. In addition, these models exhibit low coupling flatness and high directivity and up to 1 watt of power handling. The top hat construction also improves speed and accuracy of pick-and-place assemblies. Our new TCD-16-23-75X 16 dB coupler employs a patented technique to deliver excellent RF characteristics and up to 1 watt of power handling. Here you can see the typical insertion loss is less than 1.4 dB with a typical directivity of 20 dB. Our newest 1800 megahertz power splitter combiner delivers low insertion loss and high isolation with very good power handling. As an example, here you can see the insertion loss for each split port is very well behaved, with low amplitude, unbalance, and excellent VSWR. This new 2000 megahertz model has even better insertion loss and broader bandwidth. Again, the 1800 megahertz performance for both split ports is very well behaved, as is the common port. Our new LFCV-700-75 Plus is ideal for return path 684 megahertz. Here you can see the excellent out-of-band rejection and selectivity with corresponding VSWR. The RLPF-566-75 Plus is tuned for the 54 to 566 megahertz band and comes with built-in shielding. This part has very sharp roll-off and low VSWR throughout the band. With up to 40 dB of out-of-band rejection, the BFCN-152W-75 Plus delivers very low insertion loss and excellent input-output VSWR in a small 0805 footprint. In the zoomed-in plot, you can see the very low insertion loss all the way up to 1800 megahertz. In our transformer product line, we have recently introduced our ADTL1-18-75 Plus, which combines low insertion loss and return loss over the 5 to 1800 megahertz band. Having a small 0805 form factor, the NCS 1-222-75 Plus matches low phase and amplitude imbalance with low insertion loss up to 2200 megahertz. The performance up to 1800 megahertz is even better, with insertion loss well below the 1 dB typically. The TC1-33-75 G2 Plus works over an exceptionally wide band and maintains excellent RF performance, especially up to 1800 megahertz. This part can be used in balanced configuration or in balanced to unbalanced configuration. Similar, but targeted for the 1800 megahertz band specifically, the TC1.33-182X-75 Plus with a 1.33 impedance ratio is perfect for 50 to 75 ohm translation. Our JSW2 family of switches are ideal for DOCSIS 4.0, combining high power handling, low insertion loss, and high isolation with the ease of use of a built-in CMOS driver. These models have excellent input IP3, greater than 55 dBm typically, with some models as high as 70 dBm typically. The TACH-182-75 Plus is a new high current RF choke with very high current handling up to 20 amps and very low insertion loss. The 1200 megahertz version of this product has been approved in Comcast deployed equipment. Next, I'll touch on some of our roadmap products. I'll be talking about our new couplers, diplexers, and transformers. And in the following slides, we're showcasing some of our current developments focused on DOCSIS 4.0. And these products are not yet fully released, but will be available in the near term. The SYDC-9-122-75 Plus 10 dB bidirectional coupler has flat coupling, high isolation, and supports FDX. Here you can see the performance stability of this model in terms of insertion loss and coupling as a function of temperature. The companion part, SYDC-16-182-751 Plus, is rated over the full DOCSIS band with flat coupling and excellent insertion loss. Excellent return loss. The following 6 slides highlight the performance of a family of diplexers that supports high split requirements from 204 megahertz up to 684 megahertz, all maintaining low insertion loss and high isolation. Here's an example of the 5 to 204 megahertz product variant. Here's a variant for 300 megahertz cutoff. Another variant for 396 megahertz cutoff. 492 megahertz cutoff. 588 and 684. So this family of 6 products can address any system needs, again, covering from the 204 to 684 megahertz cutoff. With operation up to 3000 megahertz, the TTC1-33W-75 Plus combines low insertion loss and low amplitude and phase unbalance, and very high common mode rejection. The TCM2-182-75 Plus 2-to-1 transformer delivers outstanding insertion loss, low amplitude, and phase balance over the entire 1800 megahertz band. Again, it should be noted that the products showcased here in the roadmap section of our presentation are currently in development. Mini Circuits has an extensive design team with years of experience meeting DOCSIS requirements. If you don't find a solution on our website, please contact the Mini Circuits team so that we can develop a product that meets your DOCSIS 4.0 needs. In summary, we've seen and experienced that consumers' appetite for data is growing exponentially, driving higher data rates for both wired and wireless communication systems. DOCSIS 4.0 is being developed in response to this accelerating demand for data with higher bandwidth for wired infrastructure. This new standard presents new challenges and opportunities to deliver improved service in a cost-effective manner. Mini Circuits is poised to meet these challenges and opportunities with a diversified portfolio of high-performance products.
A special thank you to Mr. Phil McGillis for sharing his insight on the industry and market, and thank you to Eric Olson for sharing Mini Circuits product information. If you have any questions about the products that were discussed in this webinar, again, please contact MCL Marketing at minicircuits.com, and thank you again for joining us.